My name is Grant Roberson. This is Ethan Ray, and we did our project on finding a reliable assay for curcumin content in locally farmed turmeric. So what is turmeric? It's a naturally found root that is grown in local areas. It can be used in food and dyes, and it's used all over the country. Recently, studies have been coming out about its use in anti-inflammatory, diabetes, arthritis. So the root itself, as you can see, it can be dried and extracted. This is its form that most people eat. As you can see here, this is the structure. It has two benzene rings, which means it's non-polar. So if you were to ingest the natural root itself, it'll pass right through you because it's not polar, it's non-polar. So it'll usually just pass right through and you won't absorb it. So researchers are looking for ways to add things like carbohydrates and sugars onto the curcumin in order for your body to be able to absorb it.
As Grant was saying, turmeric is a very important root, and the curcumin in it is something of high interest to a lot of researchers. So we wanted to figure out a good way to extract it and to test for its concentrations. So we compared 6 different preparation methods for the turmeric rhizome in order to get curcumin out. Our first extraction, we used 95% ethyl alcohol, denatured ethyl alcohol, to after we blended it up, we mixed it with that, and that consisted of our standard solvent extraction. And then we also did a solvent extraction with an ultrasound assisted extraction by putting it in an ultrasound bath to hopefully break up some more of those chemical bonds and release more curcumin. And then we also used a microwave assisted extraction with the normal solvent to help break up some of those bonds and see if we could get more curcumin yield from that. And then we used those 3 same categories on a solent extraction preparation, where a solent extraction, it holds at the ethanol underneath it with the sample above it in an apparatus, and as the ethanol boils over, it will drip down onto our sample and dissolve and slowly extract curcumin out. We did that for 24 hours. It is just a more thorough way to extract the curcumin. And then after we had made our 6 different separation technique or preparation techniques, we took them and we put it in a spectrophotometer to measure its concentration by the spectrophotometer shines a beam of light through our samples and uses how much light is absorbed to determine the concentration. And after we did that, we compared our concentrations to a standard that we had purchased of like 95% like true curcumin, and we were able to get our relative concentrations, and they were all reading, as you can see here, in about from 3 to 7 milligrams per milliliter. Now these differences in this data, after we put in a statistical test, showed that there wasn't much significant difference in the preparation techniques, which tells us we do need to run more, have more samples and more data to get conclusive results. But if we infer from this, it shows us that our preparation techniques that we compared here might not necessarily make much of a difference. And when we've looked at the other stuff we could change to possibly make a better preparation technique, we might want to look at different solvent types, maybe a homogenizer instead of a blender to get a more fine ground and homogeneous mixture. And then we might want to look at, since the curcumin's chemical structure has the 2 rings, we might want to looking at the UV light range. But these are all future improvements we can make, and then hopefully once we have solidified our process for extraction and assaying, we'll be able to compare roots from different locations, like our locally sourced turmeric versus like out of state or out of country turmeric. And then maybe we can look at modifications to make turmeric more absorbable and all to help maybe move towards like looking at the medicinal health benefits of turmeric.